Despite the research that goes into it, weather can be a hard thing to predict. The University of North Dakota Department of Atmospheric Sciences has a research jet that's being used to gather information for NASA. Tony Grainger is here to talk with us about this jet and what he does with the organization. Thanks for coming on the show today.
Hey, great to be here.
And I mentioned the jet in the introduction there. It's a Cessna Citation 2 research jet?
That's correct.
What is this jet used for?
Well, the Cessna Citation 2 is a commercial airplane, but this particular one we have modified significantly to handle a lot of instruments and measurements that we want to take. A large number of those are in clouds.
Okay. And so what do you do on the plane?
I generally am the flight scientist, and that means that I take copious notes of what it is that we're flying through, and occasionally they ask for some sort of decision about what to do next, and that's where I would come in.
Well, how does someone get into this? How did you fall into this?
Well, I don't really have a very good answer to that. I've started off in meteorology and worked for a number of years in weather modification programs and experimental programs, basically, and these required the measurement of the cloud properties to tell if the clouds were suitable for cloud seeding. And
that's one of the biggest things that you do when you're in the air, is you're measuring things in the clouds, correct?
That's correct.
Okay. And why is this developed? The research jet to go up, why is it so important to do that kind of research?
Boy, there's a lot about clouds that we just don't know. And globally, we have a fair number of measurements now over the U.S., but we have, in essence, no information about clouds in other parts of the world, and especially places like in equatorial regions. There are very, very few measurements of the cloud properties. And one of the things that's probably not very appreciated is that if you were to take the liquid water in a cloud and change the drop size distribution by just a little bit, 10%, that would completely overwhelm the effects due to global warming and carbon dioxide. Okay. So this is really an important aspect. Well,
and important enough to have NASA backing up the research. What is this latest thing that you've been studying up in Canada, actually?
The one up in Canada was the, what is it, GPEX, Global Cold Season Precipitation Validation Experiment, I think is the proper name for it. But we were looking at what NASA tries to do is remotely sense what's going on in the clouds, how much precipitation is falling, for example.
You mean remotely from satellites?
Exactly.
Okay.
And so they have these satellites that are flying over, they're looking at these clouds, and yeah, it looks like a cloud, but what else?
Sure, and you with the jet can go through the cloud.
We can go through the cloud, we can make the measurements, we can tell how rapidly that cloud is processing water, how rapidly that water is falling out as snow. So we can make a lot more informed decisions on what that cloud really is doing. Sure. Than they can do with the satellite, but they do have some guesses by the satellite.
Yeah, and we have pictures of the plane and what is on the plane. Obviously, this is a picture up in Canada with the snow at the time, and the next picture is of the instruments. And when I saw this, I noted right away that there was ice buildup. Is that a normal thing?
It depends upon the type of clouds that we're going at, and this particular experiment was lake effect snow primarily. Okay. And there is generally a fair amount of liquid water content in those clouds, and it's below 0 degrees Celsius, so it hits the airplane and it freezes.
Are you trying to fly through inclement weather?
Oh, certainly.
So when you see a storm happening, that's a good research opportunity.
It's a good research opportunity with some exceptions. Sure. One of the things that we don't want to fly through is a hail shaft.
Sure.
We go to great pains to try to avoid that.
Yeah.
But liquid water content, super cool liquid water, icing conditions, our airplane is de-iced. So it's not like we're a bunch of cowboys out there trying to get adrenaline rushes.
Right.
We do this with a little caution.
Okay. And there's another plane that you work in conjunction with as well. It's a DC-8. It's a much larger plane. We have some video of that. I've seen the inside of the Citation. Looks really cramped, not a lot of space. This one, however, it's a passenger jet.
Oh yeah, a DC-8. They flew passengers. And you could, even I could walk down the aisle in there without having to stoop over or crawl. And the DC-8, I mean, it's got big engines, it's got lots of space, it's got hot and cold running water. I mean, it's got just lots of facilities, and it can carry a big payload. I
have to ask you this lastly here. What gets you still excited about doing this research?
It's fun. It is really fun. How many meteorologists get to go up and actually dwell in the medium that they're studying?
So instead of looking at the clouds, you're going through them.
That's right.
All right.
Exactly.
Well, Tony, thanks so much for coming on today. It was very interesting talking to you.
Well, it was good to be here.
All right.